Good, thank you. So hi everybody, my name is Amnah and I'm postdoc in Shijali Lab. So I'm very excited today to introduce you to Asari, which is our latest contribution of new open source software for LC-MS metabolomics data processing. Next. I think we cannot agree more on the fact that reproducibility of metabolite feature measurements is a key for reliable downstream analysis, and it is partly dependent on data processing tools. So with Asari, we have tried our best to circumvent some challenges of existing tools, which did not allow any easier way to verify the data because of differences in data structures and export options, and also infeasibility for processing large-scale data. Next, please. So on the left-hand side, you can see Asari architectural design. We have introduced many new concepts here, and the whole workflow is quite different from the existing tools. I cannot go on detail of every concept here, but I would like to explain one key concept here next, which is composite map. So you can imagine a composite map as a summarized representative sample, and it is cumulative signals over the all the samples, and it is later on used for peak detection. In Asari, we export annotation with the feature table as well, and we put special emphasis on data quality assessment metrics, and we include several. Next. So, for example, the C selectivity is also exported with the final feature table, and it demonstrates how distinct the chromatographic elution peaks are. Next. This is the Asari post data processing dashboard, and it allows user to navigate through the data visual inspection. So for example, you can see XICs and features here, and next, and also the different feature quality metrics. Next. We evaluated performance of Asari on several data sets, but I choose a few to discuss with you here. Next. So in the panel A, this data set consisted of 268 human plasma samples. So once we filtered feature for peak height of 1 million and later 40% samples presence, all the features of XMS are also detected by Asari. Next. So in panel B and C, we can also see good agreement between the peak detection in our two ground truth data sets. Next. And feature intensities are fairly consistent between the data sets as well. Next. We evaluated computational performance of Asari with several data sets as well, small to large. So in x-axis, in parentheses, is the sample numbers, and on y-axis, it is on log 10 scale. So we see considerable computational efficiency of Asari as compared to XMS. Next, please. So Asari is all open source. You can download the development version from Shizao's GitHub repository and our stable release from PyPI. Next. And next. So we have included two detailed guidelines here for general users and developers, and you're very welcome to contribute, use GitHub issues, report bugs, and request new features. Next. With that, I would like to thank NIH and Jackson Laboratory for generous funding support and institutional support, and my amazing colleagues in Shijali Lab. Thank you.